Thanks for having me here. It's a honor, honestly, and also given also the other speakers. My name is Sara, and I'm a senior solutions architect at AWS. As such, I help developers, IT leads, and architects translating business requirements into technology. So I work with a number of companies that are based in the Benelux, and I help them succeed implementing cloud technology in AWS. And on top of this, I would like also to add that I also used to be an AWS customer. So I myself went through with a personal experience with some of the things that I will explain today and some of the things that you might be sharing as well as developers. So let's get started. Today I will talk about monitoring microservices on AWS and which kind of data you can display in your dashboards. All right. Okay, so let me just set up the scene by talking about failure modes of a typical system. So what can go wrong in your system? It can be something within your own application. In distributed system, it could be something within your own application. Maybe somebody deployed something that has a bug, or typically what happens in every service or system, regardless of the implementation details, is that a system has a limited number of allocated resources. And if you have traffic of spikes, for instance, those resources are going to be exhausted at certain points. So that's a problem. Or sometimes the problem is not even related to your own service. It might be something that is related to a service that you're either depending on or dependable from. So this is just to set the scene. One of the things that for me is important is that we need to be able as developers to answer the question, what can go wrong? On top of what are the failure modes of my system? And in order to answer this question, I strongly personally believe that implementing monitoring tools as part of the software development lifecycle, so early on, that can really help you and your team understanding what is happening and not having this be an afterthought when it's already going live. So let's take an AWS architecture, which is based on serverless services. And this microservice, for example, is a very simple API, REST API application. So you would have API gateway that represents the entry point of your RESTful API. That interface that is integrated with an AWS Lambda that contains the business logic of your application. And let's say that you have typically this CRUD application that stores information into a table of a database, and then you have other operations like read, write, and update. And this is a typical service that you can implement in AWS. And the advantage, for instance, in this case, of these particular services that I mentioned is that they are all serverless services, and serverless means that you are not taking care of a server. AWS is taking care of that server on your behalf. So you don't have to manage cluster, you don't have to patch operating systems and so on. And there is some other additional benefits that I will say soon. When it comes to monitoring AWS services, it's more than just monitoring failure. You just also want to know, is this behaving like as expected? What is the usage of my application? And in case of failure, what is the business impact? So let me introduce another service that is AWS service, and it's called Amazon Managed Grafana. And I will give a quick intro of it. And it's a service that provides scalable, secure, and highly available data visualization for your operational metrics, logs, and traces. So with this Amazon Managed Grafana, you can create interactive dashboards and share them with anybody in your organization, and with the benefit is that you can have an automatically scaled, highly available enterprise secure service with a really minimum setup. You can set up in your AWS account if you own one, and or your organization own one. And another benefit of using, for instance, Amazon Managed Grafana is that it offloads the operational management of a normal Grafana ecosystem by automatically scaling computing and database infrastructure and usage demands. And also it covers security patching and so on. Another value is that it's integrating automatically with AWS a single sign-on, so that you can make sure that your user can log in, your teammates, and also stakeholders within your application. All right, but how does that Amazon Managed Grafana plays together with the services that I mentioned, with the application that I mentioned? So I will introduce another service, which is called Amazon CloudWatch, which is a monitoring and observability service that is built for DevOps, engineering team, developers, SREs, IT managers. And the nice thing about CloudWatch is that you can publish and store custom metrics down to 1 second resolution. And there is, so the way it would play out is that, and let me bridge with what I mentioned about serverless services, is that normally you would have to emit those data points into a entity in your environment that would collect those data points then and ingest it into Grafana. In case of these serverless services that are in this diagram, that's no longer the case. You get everything out of the box. So just by using API Gateway, AWS Lambda, and DynamoDB, you don't have to, you have some metrics that are emitted out of the box. They are ingested, created into Amazon CloudWatch, and Amazon CloudWatch can then be integrated as well seamlessly with Amazon Managed Grafana. So that really reduced the operational burden, especially if you are either a front-end developer or somebody that is a small team, or somebody or a team that operates in an enterprise, and you want to operate fast and release fast, and you don't want to spend too much time building this. So let's go to the troubleshooting side. We have a time that goes to detect, a time this goes to identify, a time this goes to remediate. Normally, you get to know that there is a problem. So let's say you are an on-call team, you want to get notified proactively about, okay, something is wrong. That you can do through, for instance, alarms based on metrics. So that's the detect phase. You get paged, maybe on PagerDuty or on Slack or something, and you get notified about the fact that, oh, there is something wrong. That's the moment when you want to identify what's wrong. And that's where monitoring, metrics, and dashboard can really help you. And after that, based on the data that you collected, you can take informed decisions to understand how can you remediate in this. All right, so let me talk a bit about metrics within AWS. Metrics are data types that can help you with the identify phase, as I mentioned. It's essentially a numeric value that is measured over time. And you can use math, sum, average, percentile. I think most people here are aware of this. And you can, of course, use the metrics in your monitoring dashboards. And within AWS, there are 2 types of metrics. So CloudWatch comes with a number of standard built-in metrics. These are automatically generated when you use Lambda, API Gateway, Lambda API Gateway, and many other serverless services. For instance, Lambda is more than 10, at least 13 built-in metrics covering invocation, performance, concurrency metrics, and so on. And remember, these are generated automatically, so you don't have to set up anything yourself. And we will look how does it look like shortly. Let me go next. So you remember I showed you this diagram. So we have API gateway, which is your REST API entry point. Then you have Lambda that does the compute. Then you have your data store that is NoSQL database, DynamoDB. So let's have a look at what information can be useful for you and you get out of the box. So these are some of the examples that you get out of the box for API gateway. So for instance, what are the request count? This is typically something that people want to know. What is the traffic that I'm getting? The latency that it takes. So that means the time that it takes from API gateway, the entry point, from the moment that it gets the request to return a response. But also maybe the latency between the entry point of your API with Lambda, which is the computing side. So what is the latency of that integration? And you get also out of the box the error. So you know how many errors, or the error rate even better, of HTTP that can be quantified in the number of responses that your API gateway returns that have either 400 or 500 status code in your response. There are other things like cache hit and miss, but these are kind of the most important one normally in your or the most common ones when you want to implement your monitoring dashboards. Then there is AWS Lambda, and in here you get invocation metrics. So for those who are not familiar with Lambda, whenever the computing unit, so the Lambda function is processing an event or an event coming from API gateway, or which is essentially the HTTP request, that's called an invocation. So every time that Lambda runs, that's the invocation, and you can get information out of this. So you can get the count, you can get the errors if something is generated. Because this is a serverless service and something that is also related to API gateway, you still exhaust the number of allocated resources. And for instance, you can get a maximum amount of invocation per Lambda per AWS region per account. And after you reach that amount, the threshold, you get throttled. So Lambda throttles the request. And this is something that you have to take into account in your dashboards to look at the errors that are related to throttling events. Other things are related more to performance, like duration and concurrent execution. And lastly, you have metrics such as that you can get out of the box from DynamoDB. And those metrics are more related to the data return, for instance, the bytes that you return, the number of items, the number of records which within each response from API gateway. Again, you get the throttle request because remember there is a finite number of allocated resources to serverless services as it is for everything. It does not scale indefinitely. So if you reach the threshold, you get throttled. So it's important to have a look at this. And yeah, you get also some performance information about the consume read and write capacity, which is also important, and the latency. Okay, just being conscious of the time, let's see an example of what can go wrong and how would that play in practice. So let's say that you have a high traffic and your application can fail at different layers of your infrastructure. So something can go wrong in the API gateway layer, something can go wrong in the compute, something can go wrong in DynamoDB. And the nice thing that I mentioned so far is that if you get, for example, throttling of events or HTTP requests or operations on DynamoDB, you can get not only alerted on this, but also notified, and you can see it in your dashboard. And that includes, that's for the example that I show, it's about throttling, but it could be about, you can get information about latency and so on. So I mentioned in so far the built-in metrics that you get. So there are two types of metrics that you get in AWS. I mentioned so far the built-in, but there are also other metrics types that are custom metrics. So custom metrics are metrics that you can publish from your code, from your compute business logic, sorry. And they are published directly from the code or also through logs. So if you write on standard output in your Lambda, you can produce custom metrics. And those custom metrics are normally typically workload specific metrics. And while the built-in custom metrics, they have a definitely a finite default dimensions that you can use to query them. The nice thing about custom metric is that you can add context, additional custom to them, custom dimensions. So let me give you an example. Something that you can, questions, failure modes that you can capture and question that you can answer with custom metrics would be, are our API consumers getting the latest version of our code? In which percentage? So in this, by adding a custom dimension to your metrics, for instance, with a commit hash or the release, the semantic release tag, you know exactly how many invocations are being performed by using an old version of your code versus a new version of your code. Another question that you can ask is that, who are the API consumers of our application? Which internal systems use our application the most? And again, you can use custom metrics to define a dimension that stores the API consumer identifier, for instance. And or another question that you can answer when you are capturing a metrics that defines a request over external dependencies. Something that you might want to know, especially if it's a dependency outside of your organization, outside of your product. Something you might want to know is, why did it fail? Is it because is there a HTTP error? So do I see a 500? Does it mean that the error is located into the dependency that I'm calling? Or maybe I don't know, maybe there is no HTTP status code. So that means that maybe this is an error on the TCP level. So maybe there is a firewall on the dependency, I'm not able to reach it. So these are information that you can capture through custom metrics and use it in your dashboard as well. So this is also as an example of, in practice, how it would look like. So maybe your AWS Lambda as an external dependency that it's returning an error, or it's even takes long to return a response. Custom metrics could be a good fit to kind of capture this information. So there are some resources that could help you getting started. So there is the documentation for Grafana in AWS. Then you have, I shared here the documentation for how to generate custom metrics by just writing those standard outputs, so creating logs, and then that will be automatically picked up by CloudWatch and integrated with Grafana. And then you have monitoring metrics through, for instance, Lambda and DynamoDB. So let me actually share in practice how it would be. I hope that my session is not expired, because this is the luck when you do demos. So this is how the managed Grafana looks like, Amazon managed Grafana. So you can create a workspace within your AWS environment, and that's essentially a Grafana environment. And that allows you, the moment you can add data sources, different data sources in your Amazon Amazon managed Grafana, and these are just some. And as I mentioned, CloudWatch is one of them. And one of the nice things also about CloudWatch, and I will show you, go to settings. So for instance, now I have, the moment that I pull CloudWatch, that I integrate CloudWatch in a particular region, for instance, in this case, it would be Dublin, I have a set of dashboard that I get out of the box. So let me show you in practice something that I mentioned in how would that look like. So I didn't have to, these are metrics that are coming from my AWS account, and I didn't have to do anything outside of just creating this Amazon Managed Grafana workspace and just using the application itself, like the architecture that I showed you before. And I can get out of the box information like invocation, so the request that my AWS Lambda is satisfied, the error rate you get as well, you get the number of throttles, you get some other information out of the box. And so, for instance, the duration, how long did it take for my AWS Lambda to return a response, and the invocation per function as well, and the error. So this is it. I hope I didn't go too much over time. Any questions so far?
Awesome. Yeah, there's definitely some questions. Thank you, Sara. Let's first look at the poll. So yes. I can share the results then. I wonder if I share the results, if I can still see it. I guess so. Yeah. Awesome. Yes. So I think most people answered that as part of their production readiness checklist, and just before going live, they'll build monitoring dashboards. Is this sort of what you expected to be the outcome?
Yeah. So I think this is good. I was optimistic, but I think this is good. I see that the majority of people at least create dashboards as part before going live. But I personally, so I see a big chunk of people also created creates the dashboard as part of the checklist. This is good. I'm not saying that this is not positive, but I think there is an added benefit by creating those dashboards earlier on in your development life cycle, software development life cycle, because knowing what's going on increases the confidence into your deployments. So you can see as you build things, imagine you're building your application code, and you can see what is the results in your dashboard, and you can have an immediate feedback, and you have this constant feedback loop that allows you to be more confident. So you don't find yourself before going live, oh, how does my application behave? I think there is a value from a confidence perspective, but also to be more understand more what are the failure modes. It forces you to ask question about the behavior of your application. So that's something that I think it's important.
I like that. That's interesting. I did see that someone mentioned that it requires quite a bit of business maturity. Do you think so, or do you think that every business could adopt this kind of thinking?
Business maturity, this idea of implementing monitoring and observability early in the cycle,
right?
You mean?
Yes. Yeah.
I think that the difficult part is explaining the value and showing the results, because I think that it can happen, and I speak also for personal experience. I didn't know myself the value, or I didn't think about it until I saw the value, and I'm like, I sort of light bulb, and I was like, well, how did I not do this before? It's like almost like a life-changing. You never go back. So I think it's normal that people don't think about it. I don't think it's about business maturity. It depends on your team. It depends on how well are you at communicating and explaining the importance, because this implementing dashboards and monitoring, it's something that takes time, and you gotta have to convince also the product manager that this is important and what is the value. So not only for your team, but also for the product manager, and they're like, yeah, I mean, we wanted to release the MVP this day, but probably it's going to take longer because we want to also make sure to implement this side, these things. And you have to be speaking a language that explains clearly the benefit also from a product perspective. Yeah.
Right. Awesome. Thank you. I think in the interest of time, we're going to the next presentation, but there are a couple of questions in the chat. So if you could jump in the chat and answer those, that'd be awesome. Thank you so much.
Absolutely. Thank you. Thanks,
Sarah.
everybody.